What is an inverse function? An inverse function is a function obtained by expressing the dependent variable of one function as the independent variable of another. Don't worry, it's not as bad as it sounds. To put it basically, an inverse function undoes whatever your original function did to your independent variable. To help show this, we'll look at an example. In the function y equals x squared, x represents your independent variable and y represents your dependent variable. If we let x, the independent variable, equal 3, we obtain y equals 3 squared. We know that 3 squared is 9, and thus 9 is your dependent variable because it depends on x being 3. The inverse equation of y equals x squared is y equals the square root of x. So if we take our dependent variable from the previous equation, 9, and plug it in for x here, we get y equals the square root of 9. We know that the square root of 9 is 3, and so for the inverse equation, our dependent variable is 3, which was the independent variable for the original function. So we put 3 into the original function and we got 9. We put 9 into the inverse and we got 3. So we undid what the original function did. Now I'll show you how to find an inverse function. To find an inverse, we need an original function to work with, so we'll use this one because it's simple. The first step in finding an inverse is switching the variables. So you put x in y's place and y in x place, and then you want to solve out back to a y equals form. So we'll divide both sides by 27, and as we know from algebra, the 27's cancel on the right side, and you're left with x over 27 equals y cubed. To get y by itself, we need to multiply both exponents by 1/3. When we do this, we get x to the 1/3 over 27 to the 1/3, and we know the cube root of 27 is 3, and y to the 1/3 times 3 is just y to the first. To put it in a friendlier notation, we'll just put a cube root sign over the x instead of a 1/3 exponent, and we'll flip the sides to get it back into your standard y equals equation. It's always good to do checks when you're doing math, so we're going to take our original equation and give ourselves a value for our independent variable, and we'll use 2. So we have y equals 27 times 2 cubed. 2 cubed is 8. So we've got y equals 27 times 8, which is 216, and that's our dependent variable for our original function. So we'll plug that in as the independent variable in the inverse function, and we'll end up with y equals the cube root of 216 over 3. The cube root of 216 is 6. I know that, you don't have to check the calculator. So now we're down to y equals 6 over 3, which reduces to 2. And since 2 was our independent variable in the original, now it's our dependent in the inverse, we have successfully created an inverse function. This is the graph of y equals x squared, your basic parabola. It's also the function we were dealing with originally, and this is that same graph with its inverse function also graphed. The red line is there because the inverse function isn't truly a function, it fails the vertical line test, but it's important that you see the shape of it so that you can compare it to the original. It looks as though it's just been turned to the side. If you bear that in mind, I can show you a trick to check yourself when you're graphing out the inverse function that you derive. This is the function, the graph of the function y equals 27x cubed, which is our original function. If you reflect it across the y-axis, like so, you'll have to visualize this just kind of in your mind as you're graphing out your inverse function, and turn it 90 degrees clockwise to the right. You have a curve. The numbers are flipped, that's not important. The important part is that you see the curve, because when you compare it to the actual inverse graph, which I have here, y equals the cube root of x over 3, you can see that the curve from the manipulated graph and this graph are the same. So that's a trick you can use to check yourself as you're graphing out your inverse function.